In this section, we will examine several advanced option strategies. One type of advanced strategy is a spread. A spread involves the purchase of one option and the sale of another option, both on the same share of stock. Spreads can be characterized as a strike spread, also known as a vertical or money spread. In these, the two options will have different exercise prices, but have the same expiration date. For example, we might buy a call with a $20 exercise price and write another call with a $25 exercise price, but both expire in the same month of June. An alternative is the time or horizontal or calendar spread. These differ by the expiration date, but will have the same exercise price. For example, we might write a call with a January expiration and buy a call with a June expiration, where both have the same exercise price of $25. Why do investors use spreads? Spreads offer the potential for a small profit while limiting our risk exposure. Also, spreads are useful in modifying risk while allowing profits if our market forecasts prove to be correct. By market forecasts, we mean the movement in the underlying stock price. Finally, because spreads involve several transactions, trading costs may be prohibitive. The first type of spread we will look at is a money or strike spread. In particular, we'll look at a bull spread. If we have two options, one with a low exercise price we'll call X1, and the other with a higher exercise price we'll call X2, then we know that the premium on the first option will be greater than the premium on the second option. The strategy here is to buy the call with the low exercise price and write the call with a higher exercise price. Our profit will be the profit on the first call, which is the maximum of 0, or ST minus the exercise price on that first option, minus the premium on the first option. The second option we are writing, so the quantity here is -1, and we'll multiply that by the maximum of 0, or ST minus X2, that is the strike on the second option, minus the premium on the second option. Let's look at a bull spread. Here, we're going to buy the call option with a premium of 3 and an exercise price of 8. In addition, we will write the second call option, which has a premium of 1 and an exercise price of 12. Let's start with the first option here. This option has a premium of 3, so that we know that when we buy this option, we will lose that $3 premium. For any stock price less than the exercise price of 8, the option expires out of the money and we simply lose our premium. So we can draw the payoff to the first option here. Once the stock price rises above 8, we know that for each dollar the stock price rises, the option will gain $1 more in value. So we can use the 1-to-1 payoff rule and plot the second part of this option's value. So this is buy a call. Next, we'll plot the profit from the second option. We'll do that in red. Here we're going to write a call with a premium of $1 and an exercise price of 12. So we're going to collect or pocket that $1 premium, and for any stock price less than 12, the option expires out of the money and we will simply pocket the premium. If the stock rises above 12, however, the option will go in the money. As the writer of the option, we will lose as it goes in the money. Again, we can use our 1-to-1 payoff to plot the payoff to the written call at high stock prices. For the combined payoff, we'll add the two lines together for various stock prices. We'll start at a stock price of 0. We've got +1 on the red line, -3 on the green line. Add those two together, and we get -2. We'll come over to the first exercise price. Here we have positive 1 on the red line, negative 3 on the green line. Again, negative 2 is the combined payoff. Next, we'll come over to the $12, the second exercise price, and we'll add the two numbers together. When the stock price is 12, the red line is at 1, and the green line is also at 1. So 1 and 1 combine to 2. And finally, we'll look over here on the right-hand side. When the stock price is 20, on the green line, we have a positive profit of $9, and on the red line, we have a loss of $7. 9 minus 7 gives us 2. We can plot our last point. We're now ready to plot the combined profit at intermediate stock prices, and finally at high stock prices. We can indeed see that this is a bullish strategy. It profits when stock prices are high and loses when stock prices are low. Note also that because it is a spread, that it limits both our losses and our gains. Next, we will examine a bear spread. In a bear spread, we will write the call with a lower exercise price and buy the call with a higher exercise price. We're writing the first option, so its quantity is negative 1 times its intrinsic value at expiration, the maximum of 0 or S minus X, less the premium we paid to buy the first option at time 0. Here's the profit on the second call. We're buying that call, so the quantity is positive 1, again times its intrinsic value minus the premium we paid at time 0 for that option. Let's look at a bear spread example. Here we're going to write the first call. It has the premium of 3 and the exercise of 8. We're going to buy the second call with a premium 1 and an exercise of 12. So if we write an option with a premium of 3, we will collect that $3 premium, and we'll do so at any stock price less than $8. Once the stock price rises above 8, the option goes in the money, but as the writer of the option, we will lose money. So we can use our one-to-one technique to show us what our profits will be at varying stock prices between $8 and $20. So here's the first part of the position. Write call number 1. Next, we'll look at buying call number 2. Call number 2 has a premium of $1, so we will lose that dollar as soon as we buy that option. It has an exercise price of 12, so for any stock price less than 12, the option expires out of the money and we lose our $1 premium. If the stock price rises above 12, however, the option goes in the money, and for each dollar that it rises above 12, we can make an additional dollar of profit. So we can plot the profit at high stock prices for options number 2 here on the right side. So this is buy call number 2. Lastly, we want to combine the two lines together, see what our combined payoff looks like. If the stock price is 0, we have $3 on the first call, negative 1 on the second call for a $2 profit. If the stock price is 8, that is the lower of the two exercise prices, then we have a $3 profit on the red line and a $1 loss on the blue line. So positive 3 minus 1 gives us $1. We'll go to our second exercise price. Here we lose $1 on the green line and $1 on the red line. So negative 1 plus negative 1 gives us negative 2. Finally, we'll go over to the right-hand side of our chart. We have $7 on the green point and negative 9 on the red point. 7 minus 9 gives us negative 2. We'll be right here. So now we can join our points together. Okay, a bear spread implies that the strategy should profit with falling prices, and indeed it does. We can see the bear spread, the black line, profits along here from stock prices from 0 to 8 and loses over here with stock prices from 12 to 20. So indeed it profits as stock prices fall. The butterfly spread is a more complex strategy. Here we're going to buy two calls, one with a low exercise price and one with a high exercise price. We're also going to write two calls with a middle exercise price. We'll call that one X2. So here's our profit from the first call, the one with the exercise price of X1. It's the maximum of 0 or ST minus X1. It's intrinsic value at expiration minus the premium we paid to buy option number 1. We're going to write 2 of the second call, so we've got a quantity of minus 2 here. Again, we're going to multiply that by its intrinsic value at expiration. There's no time value. All that's left is its intrinsic value minus the premium we paid to buy option number 2. And finally, here's the profit from the third option. We're buying that option, so the quantity is positive 1. At expiration, it only has intrinsic value, so we'll take that intrinsic value and we'll subtract the premium we paid to buy the option, again at time 0. Here are the assumed option prices and premiums, or strike prices and premiums. The first call has a premium of 3 and a strike of 8. Second has a premium of 2 and a strike of 10. Third option has a premium of 1 and an exercise or strike of 12. So here's the chart of our butterfly spread. Again, we're going to buy the first call. We're going to write 2 of the second call. And finally, we're going to buy 1 of the third call. Let's use our green pen to denote the first call option. This call option has a premium of 3, so we know we will lose that $3 premium for any stock price less than $8. Option is out of the money at low stock prices. We simply lose the premium we paid. As the stock price rises above 8, we make $1 in profit for each dollar that the stock price rises. So we can plot the payoff to the first option at high stock prices along this section of the line here. So we'll label this by call number 1. For the second call, we're going to write 2 of those. I'll use the red pen to denote writing options. Now, we need to be a little careful here. The option has a premium of 2, but we're going to write 2 of those options. And so we get 2 times 2. We get $4 in premiums when we write 2 options. So that's 2 times C2. Okay. This option has an exercise price of 10. So for any stock price less than $10, we will still have our $4 profit. That is, the options expire out of the money. We get to pocket and keep the $4 in premiums. Option expires out of the money. The next part of the line is the tricky part. If the stock price increases by $1, then we lose $1 on each of the 2 options. So I'm going to go $1 to the right and $2 down. And there's going to be our profit. Again, we make or lose $1 on each of the two options when the stock price increases by $1. We'll have to do the same technique to find our payoff for this option. We'll go to the right, $1, stock price increasing by 1, and down $2. We lose $1 on each of the two options that we have written. We're seeing something new now. This line has a 2-to-1 slope. All the other lines we've drawn so far either had no slope, the flat lines, or a 1-to-1 slope. For example, our green line up here has a 1-to-1 slope. So we'll label this line right 2 of call number 2. Finally, our third call has a premium of 1 and an exercise price of 12. So we'll come down to -1 on the x-axis. We'll go over to a stock price of 12. And there's the out of the money range for that first option. So at low stock prices, we pay the $1 premium. The option expires out of the money. We lose our $1. However, if the stock price rises above the exercise price of 12, the option goes in the money, and for each $1 that the stock price increases above 12, we make another $1 of profit on that option. So we'll label this one by call number 3. We're now ready to combine the 3 lines and see what our combined payoff looks like. We'll start over here when the stock price is 0. In that case, I have $4 on the red line, -1 on the blue, and -1 on the green line. We add those numbers together, we end up with $0 of profit. We'll move over to the next exercise price, which is 8, and add our lines together again. So when the stock price is 8, on the red line we have 4, the blue line is -1, and the green line is -3. So again, those numbers add up to $0. So at low stock prices, we can plot our combined payoff along this section of the line here. Our next exercise price is the middle one at $10. We'll have to be careful here. When the stock price is 10, our red line is at 4. Our green line is at -1, and our blue line is also at -1. So I've got 4 minus 1 minus 1 gives me $2. So we'll get to this point here. We'll move over to the next exercise price of 12 and add the 3 profits together there. When the stock price is 12, our red line is at 0. The green line is at +1, and the blue line is at -1. So we'll add those 3 numbers together, and again, we'll get 0. It'll plot right here. Finally, we'll come over to the right-hand side where our exercise, or stock price rather, is 20, and we'll add the 3 lines together. Our red line does not make it all the way over to the right-hand side of the chart. So we'll use $18 and add up our prices there instead. So when the stock price is 18, our red line is at -12. Our blue line is at 5, and our green line is at 7. Those add up to 0 in this case, so we'll be right here when the stock price is 18. We can go ahead and combine all the points with our line here, kind of see what happens. The black line is our butterfly spread. Let's have a look at this line and see what's going on here. At low stock prices, our profit is 0 over a large range. Then it rises to a maximum of 2, falls back to 0, and remains 0 over a long range. Now, a word of caution. The option premiums that I assumed up top here are rounded to the nearest integer. And that's why when we add these things together, we get exactly 0. If we were to do this with real option quotes, we would get a number probably slightly smaller than 0 for our profit over this range here, and also for this range here. It's only because I've rounded those option premiums to the nearest dollar that we see this effect. What's important, though, is here in the middle. Look at what's going on here. Our profit is maximized if the stock's price stays at $10. Remember, that was our original stock price. Even though there's no share of stock in this example, we generated the option quotes using an assumption that the stock price was $10. In other words, we generate our maximum profit if the stock price remains unchanged. So what we see here then is that our profit is maximized when the ending stock price is equal to our beginning stock price. In other words, we have no volatility. So the butterfly spread then is a bet that the stock price will remain constant and will not vary between now and the expiration date of the options. On the other hand, our loss is maximized at either very low stock prices or very high stock prices. So no volatility leads to maximized profit, and volatility will lead to losses. Next, we'll have a look at a strategy known as a straddle. In a straddle, we buy a call and a put with the same exercise price and time to expiration. Let's think about this for a moment. We're buying a call, so that will pay if the stock price rises. We're also buying a put. That will pay if the stock price falls. So now we have a strategy that makes a profit if the stock price rises or falls. However, there must be some middle ground, and we'll see that if the stock price does not move, then we have a loss. So we're going to buy a call with a premium of 3 and an exercise of 8. We're going to buy a put with a premium of 1 and an exercise of 8. Same strike price on both of those. Here's our profit equation. For the call, remember we're going to hold these until expiration. There is no time value. The only thing that's left is intrinsic value. So we have the intrinsic value of the call minus its premium. And for the put, likewise, it has only intrinsic value at expiration, no time value. And so we'll take its intrinsic value at expiration minus the premium we paid to buy that put. We'll begin by plotting the payoff to the call option with a premium of 3 and an exercise of 8. To save time, I'll turn off the recording while I draw this diagram. Okay, so we've plotted the payoff to the call here. We pay the $3 premium to buy the option. It's out of the money for any stock price less than 8. And then it goes in the money. For each dollar that the stock price rises, we make another dollar. Stock price rises, we make another dollar, and so forth. So we can draw the right-hand portion of our line heading out here. Next, we'll draw the profit from the put option. Again, I'll turn off the recording. The put has a premium of 1 and an exercise of 8. So we know we'll pay that $1 premium. We'll come down to -1 and over to the exercise price of 8. And there's our first point. At any stock price higher than 8, the put option expires out of the money and we merely lose the $1 premium. For stock prices lower than 8, if the stock price falls $1, we gain $1. If the stock price falls $2, we gain $2, and so forth. So we get this 45-degree line. We know that the maximum profit is up here. When the stock price is 0, our maximum profit is X minus P. 8 minus 1 is $7. Finally, we'll draw the profit from combining these two assets together. So if the stock price is 0, then I've got 7 minus 3 gives me $4 is my combined profit. Next, if my stock price is 8, I've got minus 1 minus 3 gives me minus 4. And finally, over here on the right-hand side, if the stock price is 20, I've got 9 minus 1 gives me $8. We can combine these points with a line. See what our combined payoff looks like. Here's our combined payoff. I'll just call it the combo. Let's have a look at this V-shaped line, which is our combined payoff, or our straddle. We can see that our profits, or losses rather, are maximized right here in the middle, when the stock price stays relatively constant. So again, this is a type of volatility play. Maximum loss if stock is not volatile. On the other hand, our losses are out here in the right and left-hand tails. So we get our maximum profit from large movements in the stock price. So a straddle is a bet that the stock will make a large movement in an unknown direction. As an example, a company might be the target of a lawsuit. If it wins the lawsuit, we might expect its stock price to rise substantially, and if it loses the lawsuit, we might expect its stock price to fall substantially. We can spot the break-even points. Those occur when our stock price, or rather our profit, is 0. So we have one break-even point here around $4, and another break-even point over here around $12. So for any stock price between 4 and 12, we lose money on the straddle. On the other hand, if the stock falls below 4 or rises above 12, then we make money with our straddle. So again, we're betting on a large movement or lots of volatility in that stock price. The next strategy we'll examine is called a strip. In a strip, we're going to buy 2 calls and 1 put, where all of those have the same exercise price and the same expiration date. Now, before we even start our diagram, let's look at what we have here. 2 calls, but only 1 put. So the put will profit if the stock price falls. We have 2 calls, each of which will profit if the stock price rises. These are going to double our profit when the stock price goes up relative to what happens when the stock price goes down. Here's our premiums. The call has an exercise of 3, a premium of 3 and an exercise of 8. We're going to buy 2 of that same call option, and then our put has a premium of 1 and an exercise of 8. Our profit equation is here. Our quantity for the calls is now 2. We're buying 2 calls. Remember that at expiration, any option only has intrinsic value. There's no time value left. So we'll take its intrinsic value at expiration and subtract the premium we paid to buy that option. Likewise, for our put at expiration, it has no time value, only intrinsic value. So we'll take the intrinsic value at expiration and subtract the premium we paid to buy the put. Let's plot the profit from our calls first. The calls have a premium of 3 and an exercise of 8. We're going to buy 2 of those calls. So we're going to pay $3 for the first one and $3 for the second one. And so the total cost is going to be 2 times C0. We're going to have to spend money to buy each of those call options, but the exercise price is still 8. So we can draw a flat line from there over to $8, And there's our out of the money line segment for the calls. Then the options go in the money when the stock price rises above 8. Again, we have to be careful here. If the stock price rises by $1, we make $1 on the first call and $1 on the second call. So we get $2 of profit for each $1 change in the stock price. The same happens again. If the stock price rises to 10, we have a $1 increase in the stock price, but a $2 increase in our profit because we have two of those call options. And so we can draw a line like this that shows our payoff from the call options. Again, this line has a 2-to-1 slope because there are two calls in the strategy. So we'll buy two calls. Next, we'll write the put options, buy the put options. I'll go ahead and put the puts in red here for us. The put has a premium of 1, and we're only buying one of those put options. So we'll come down to -1 and the exercise price of 8, and we'll draw a point there. Any stock price higher than 8, the put expires out of the money, and we lose our $1 premium. So we can draw the flat line over to the right. Now, we know that the maximum profit on a put is X minus P. 8 minus 1 is $7. We could draw the point there, or we can just use our 1-to-1 relationship. We know that every time the stock price falls by $1, the put makes $1 more of profit. So there's the payoff from our put option. Lastly, we'll combine the two lines together and see what the payoff looks like. If the stock price ends up at 0, we make $7 on the put, and we lose $6 on the call. So our combined profit is 1. If the stock price is 8, we've got -1 on the green line and -6 on the -1 on the red line and -6 on the green line. So -1 minus 6 gives us -7. That'll plot right down here. And then we can't see all the way off to the right-hand edge, so we'll use 17 here. That's as far as the green line is available to us. If the stock price ends at 17, our green line is at 12, and our red line is at -1. 12 minus 1 gives us $11. Okay, we can now combine our three dots together and get our total payoff. Notice for the strap that the line looks a lot like it did for the straddle. It's a V-shaped line. Our maximum loss occurs here when the stock price is relatively unchanged. Our profits occur on the left-hand side and the right-hand side of the diagram. But there is one big difference between this diagram and the previous one for the straddle. And that's this 2-to-1 slope on the right-hand side. That's true for both the green line and for the black line, the combined payoff, which I did not label earlier. We'll go ahead and do that now. There we go. We can also see our break-even points. Break-even occurs when we have no profit. So we have one break-even point over here on the left-hand side at a stock price of $1, and another break-even point over here on the right-hand side, and that occurs at a stock price somewhere around $11 or $12. My diagram is not exact here, and so it's hard to read the scale exactly. So for intermediate stock prices, we lose money. We have to pay for the premiums on all three of those options. But for extremely low or extremely high stock prices, we make money. Now, the right-hand side is what's particularly interesting over here. Why would we set up a strap rather than a straddle? Kind of looks like a straddle on the left-hand side. We have a 1-to-1 slope. Every time the stock price goes down, we make $1 more profit. The interesting part is over here on the right. Each time the stock price rises, we make $2 of profit rather than $1 of profit. And so it must be the case that we think the stock could go down or could go up, but we think the increase in stock price is more likely. We've bought more calls, 2 of them as a result, and so we make twice as much profit when prices increase as we do on the put when prices decrease. So there's an asymmetry in our expectation here. We believe the stock price could fall a lot or rise a lot, but for some reason we think it's more likely to rise. Let's have a look at the strip. With the strip, we're going to buy 1 call, but 2 puts. So that should tell us something. We're going to make twice as much profit when prices decline as we do when prices rise. So here's a strategy that's going to pay off in either direction, but pay off more when stock prices go down. The call is the same one we saw before, as is the put. The only difference is the quantity. We're buying 2 puts and only 1 call. I'll turn off recording for a second while I draw the call option. So here's our call option, just as we drew before. The premium is $3, so we come down to -3. We draw a straight line over to the exercise price, which is 8. And then for each dollar that the stock price rises above the exercise price, we make another $1 of profit. Another $1 of stock price rise, another $1 of profit. And that gives us this line here. Now we'll draw the put options. The put options have a premium of 1 and an exercise price of 8. Recall we're going to buy 2 of those put options. And so 2 times 1 is $2. We'll pay $2 in premiums. So we'll come down to -2 and draw a point here. Any stock price higher than $8, the puts will expire out of the money. And so we have a flat line off to the right. Off to the left, the story, of course, is going to be a little different. If the stock price falls by $1, we will get $2 of profit, 1 on each of the 2 puts. So I'm going to go over here to $1 to the left, and then up $2 and draw a point there. We'll do the same again. Go to the left 1 point, and up $2, draw a point. Over 1, up 2, over 1, up 2, and keep doing that until we run out of space here. We'll connect these points with the lines, just as we did before. If we continued this red line all the way up until it hit the y-axis, we go $1 more to the left and $2 up. So we'd hit it $14 on the y-axis. So we have $14 of profit on the put and $3 loss on our calls if the stock price is 0. So 14 minus 3 gives us, what, $11. Next, we'll look at the exercise price, which is $8 for both the call and the put. If the stock price is 8, we lose $2 on the red line, the puts, and we lose $3 on the green line, the calls. So -2 plus -3 gives us -5. We'd be down here. Finally, we'll come over to the right-hand side. If the stock price ends up at 20, we're going to lose $2 on the puts and make $9 on the calls. 9 minus 2 gives us $7. We can connect our black dots with a line and see the payoff to our strip. Okay, let's have a look at this combined payoff. As it did before, we have a V shape, but it's not symmetric. On the right-hand side, the slope here is 1-to-1. But on the left-hand side, the slope is 2-to-1. That's because we have two puts. Each pays $1 of profit when the stock price falls by an additional $1. We can also see our break-even points. Break-even occurs, of course, when our profit is 0. So we have one break-even point here on the left and another break-even point over here on the right. So at stock prices between about 5.5 and 13, we have a loss in this middle range. And then outside of that range, we have our profits. Because we have two put options, the line is steeper on the left-hand side, and that means we must have some expectation. Although the strategy will pay off regardless of whether stock prices fall or rise. If stock prices do fall, then we make profit more rapidly. Each time the stock price moves $1, we get $2 of profit. As before, our maximum loss occurs when the stock price is stable. This concludes our review of the advanced option strategies.